here we are. It has finally arrived. Our last video on solving our truss right here, step by step. So we have solved each one of these members, and today we are left with just this one, member DB. So we're going to go through and we're going to isolate this at point D and solve for the force right here in this member. Okay, and then we're going to make sure that all of our free body diagrams are updated. You'll be done and be able to submit this assignment. Okay, so let's get started. Alright, we want to calculate dB, so the first thing that we need to do is draw our free body diagram. Well, here we go. We have point D right here. Okay, so D, I'm going to use my ruler. We have this member going across right here, so I'm going to go ahead and draw this, our line segment for DE. Okay, then we have going down to DB, right there, and then last but not least, we have our little line segment going off to point A. So this is what we have. Okay, so there's our members and our joint for D. Okay, so we have this segment right here, which is DE, this segment right here, which is DB, and then this one, which is DA. Okay, alright, so we're going to do this. Now we need to include our forces that we have. So if we went all the way back, you would have negative 1,378.9, okay, 9 pounds there. Right here, this is the one we're solving for, so we don't know that yet. So in this one, we have negative 960.56 pounds, okay. We have an angle right here of 56 degrees, okay. And when we're coming down from this point right here, this angle is 45 degrees. Not all the way through here, just to this point. Okay. Alright. We also have coming down from right here 1,000 pounds. Okay. Alright. So that is what we have. Okay. So there you go. Alright. So now, let's see. We're going to be solving like for dBy and dBx. So if we're going to go to B right here, I'm going to go ahead and draw our dotted line right here. So this would be dBy. Alright. And then right here, even though this says dE, solving for this part would be dBx. Okay? Alright. Well, I guess if you wanted to do it like this, we would have, here's that point. Okay? Alright. So that's what we have at this point. Okay? Alright. So there you go. We have our free body diagram that we have going on. Okay? Now they want us to calculate dBy. So we're going to be looking for this because these two forces, our dBx and our dBy, is what's causing this vector right here. Okay? So y. So if we're looking for dBy right here, here's my angle. This is opposite over hypotenuse. So I'm going to put sine of my angle equals opposite over hypotenuse. Okay, so we'll sub in. So we're going to do sine of 56 degrees equals dBy over dB. Okay, so if I'm getting dBy out, then I would just multiply dB over. So then I end up with the sine. I guess I can just, that's fine. Sine of 56 times dB. Okay? Alright. Now for dBx. Here's my dBx up here. So my equation is going to be cosine my angle, because I have my adjacent over my hypotenuse. So I'm going to write equals adjacent over hypotenuse. And we're going to do substitute. So we have cosine of 56 degrees equals adjacent. So we're going to have dBx over dB. Okay, so now I substitute out. I want dBx by itself, so I'm going to have cosine of 56 degrees times dB. Alright? Okay, we have those. Alright, so we're good. Okay, so far so good. Going along really well. Alright, now let's go on over here to our last page. Look at that. Celebrate. It's our last page. Good job. Alright, so we're going to list all of our known forces in our x direction. Okay, so every known force that we have. Okay, so you might have to like flip back through your pages, so I'm going to kind of skip up through here and take a look. There's page 6 there. Okay, so in this case we should have so in our x direction, we're looking for our forces in our x direction. I had to go find my free body diagram back all the way from question 1 that we've been updating as we kind of go along. Okay, so I'm looking for all the forces that are interacting with these couple of things at this point. Okay, so right here in my x direction, I have that's going this way, acting right here. I have this 975 pounds. Okay, so I have 975 pounds going this direction. I'm going to use this arrow right now because I'll come back and talk about that in a minute. Okay, then we also have a force right here from our last time that we were working. Is we have up here this force that's going this direction, which is going to be, I know this says 900, well it's negative 960, but I'm going to write 960.5. It's going that way. So there we go. And then from our equation that we just did right here for our x direction, we're going to have cosine of 56 degrees times dB. Okay? Alright. Now, this, because it's going, this force, because it's going to the right, will be positive. This force, because it's going to the left, will be negative. Okay? Just like it shows up here. Alright, now forces in the y direction. What do we have in our y direction? Well, I do have 1,000 pounds coming down. Okay, so 1,000 going in that direction, right? And then in one of our earlier questions, we also have 975 pounds that is going, where'd it go? Oh, there it is. And we have 975 pounds pushing up over here, okay? Right? So we do have those forces, 975 pounds going up, right? And we also have in the y direction sine of 56 degrees times our dB. Okay? Alright. Now, with our sines going up that we have here, our 1,000, because it's going down, is going to be negative, okay? And our 975 going up will be a positive force, okay? All right. Good so far? All right. So here we go. Now we're going to use our equation, our final summation equation. So we're going to look for the sum. I did it again. Sum equals our force in our y direction. Should equal 0. Okay? So I'm going to plug in my values that I have. Okay? So we are looking for dB. Sorry, we have 975 pounds. It's going this way. Okay? Or sorry, it's going this way. 975 pounds minus our 1,000 minus our dB sine of 56 degrees. Okay? So now we're going to kind of simplify this. So if you do 975 minus 1,000, you should end up with negative 25 times dB sine of 56 degrees. Okay, so we continue on. I want to get dB by itself. So if I just take this, we're going to have so I end up with negative 25 dB over here on this side. Negative 25 divided by the sine of 56 degrees. Okay? Alright? Are we good? Hopefully we are good. Alright? Okay. And now we solve. So there you go. You plug this into your calculator. You're going to answer the question as it pops up. And hopefully you came up with negative 30.2 pounds. Okay? So we have this right there. So we're going to update our free body diagram. We're all done. We don't have to do anything else because we have everything else solved. That was it. Okay? So I can come back in here. Here's my free body diagram. So this is negative 30.2 pounds. Now, here's what I would like you to do. Okay? Down here in number, this very last one. Okay? You need to redraw the truss from number 1. Okay? And draw the complete body diagram. So you're going to draw it all out. Similar to this. Okay, actually here. So you'll redraw this part out. Okay, this has, we have our forces here, but then you're going to go back in and fill in all the reaction forces, fill in the angles, and then fill in the values for each member. Okay, be sure to include positive and negative. All right, when you have that done, you're going to take a picture of each page. I do not need a picture of page 1 because there was nothing there, but you're going to take a picture starting with page 2, then page 3, and then page 4, and so on. You're going to take a picture of each one. If you want to use an app like Cam Scanner and put it all in one file, that's great. If you want to add them into a Google Doc and like insert all your pictures as one file, that's great. If you want to upload each individual picture, anything works. But I need every picture uploaded and turned in for this assignment. It is a major test grade, I'm going to be looking to make sure each one of these boxes are complete. So you should have information for every single thing. You should have each little isolated free body diagram completed. And when you have those all done and pictures taken, you should be good to go to turn it in. All right? This is due today. So we've been working on this for 4 days. You should be following along. Should not be hard. Good luck. If you have any questions, you can reach out to me through email, or my Zoom link is there. So when you click on it, it notifies me, and I'll log in and answer any questions that you have. All right? Good luck, and congratulations for completing this monstrous activity.